I would suggest that you pause the video and try these two warm-up problems really quick. Okay, hopefully this is what you came up with these warm-ups. These concepts here are going to be important for some of the concepts that we're going to be talking about. So make sure you know how to do these, and if you don't, make sure that you send me a message and I can answer some questions. Today we're going to continue with complex numbers, which was section 1.4. We are going to be dividing complex numbers today, as well as performing operations with square roots of negative numbers. So, a conjugate of a complex number. In your homework, we saw something like this, where we were multiplying two binomials that looked very similar, but notice that one had an addition sign and one had a subtraction sign. When we multiplied, the middle terms of I ended up canceling out, and then that last term turned into I squared, which then resulted in us turning it into a real number. So our final answer ended up being a real number only. The idea behind this is called a complex conjugate. So our definition is if you have two binomials that are essentially the same, but one's addition and one is subtraction, it ends up turning out when you multiply that it turns into a squared plus b squared. So those middle terms with the i's end up canceling out. And it doesn't matter if you have the addition sign first or the addition sign second, as long as the two binomials with the terms of the real numbers and the imaginary numbers, as long as they are the same. So we're going to be using these complex conjugates to divide complex numbers. So to divide complex numbers, we never want an imaginary number in our denominator as our final answer. So therefore, how are we going to get rid of those imaginary numbers in our denominator? Well, we're going to multiply both the top and the bottom of the fraction by that denominator's conjugate. And that's going to allow us to then cancel out those middle terms of i's, and then the imaginary numbers will no longer be in the denominator. And so it's okay if you end up with your numerator with imaginary numbers. We just never want the denominator to have imaginary numbers. So here's our first problem. We're going to divide, and then we're going to make sure that we write our final answer in standard form. So remember, standard form, first number is the real number, and then the second number is the imaginary number. So as you can see, 2 divided by the binomial of 5 plus I. Because we have this binomial here where there is an imaginary number, our definition is then in order to divide, we want to multiply by the conjugate. So I'm going to multiply both the top and the bottom by 5 minus I. So notice how they're almost the same, but it's the sign in the middle that is different. Okay, so you have to do it to both the top and the bottom. When you multiply fractions, you multiply straight across. So essentially that 2 is going to have to get distributed to the 5 and the negative I. So 2 times 5 is going to turn to 10. 2 times negative I would be negative 2I. Now I want to multiply out the denominators. So remember, the whole point of this conjugate is that the middle terms of I are going to cancel. So we will have 5 times 5 if I start distributing. So that would give me 25. Notice how this would be a negative 5I. Moving to the I, that would be a positive 5I. So that's why those cancel. And then I times negative I. Well, a positive times a negative is a negative, and I times I is I squared. And so remember, the whole point is that the I squared term really is going to turn into a negative 1. So I still have that subtraction sign, but now I'm subtracting negative 1. So notice my denominator no longer has any imaginary numbers. And so because my numerator doesn't have any like terms, that's still 10 minus 2I, but 25 minus a negative 1 is going to give us then 26. This is not my final answer because it's not quite in standard form. I'm going to go ahead and split apart the fractions. As long as I only have one term in my denominator, I can split up the term. So it turns into 10 over 26 minus 2i over 26. So there's my real number followed by my imaginary number. But notice how we can reduce. 10 and 26 are both even. So if I reduce them both down by 2, we get 5 over 13. And then the same idea here. 2 and 26 reduce down. So you can even think of it as then like 1 over 13, and then you can just put the I at the end. You can keep the I in the numerator. They're the same exact thing, but the I is no longer in the denominator, and here is my standard form answer. So same idea, we're going to divide and then write our answer in standard form. Notice that my denominator has an imaginary number. Notice my numerator is also a binomial, but I focus on the denominator to figure out the conjugate. So if I see 4 minus I, that means I want 4 plus I in the denominator. And if I multiply the bottom by that, I have to multiply the numerator as well. All right, so we got a little bit more algebra this time because in the numerator now we have a binomial times a binomial. So once again, I'm going to distribute. 5 times 4 is going to give me 20. 5 times I is going to give me a positive 5i. Moving on to the 4i, that times 4 is going to give me 16i. And then 4i times I is going to give me a positive 4i squared. Okay, now my denominator, the whole point is if I picked the conjugate correctly, the middle terms of I will cancel. So 4 times 4 is 16. 4 times I is positive 4i. Notice that now if I distribute a negative I over, that would give me a negative 4i, so those middle terms cancel. Negative I times positive I is a negative I squared. In my numerator, I've got 20. I've got some like terms. So 5i and 16i would be 21i. Notice that the 4 now is going to be multiplied by a negative 1 because I no longer want that to say I squared. In my denominator, we'll have 16 minus, and then once again, I get to replace that I squared with negative 1. My numerator has some like terms that I can combine because 4 times negative 1 is negative 4, and 20 minus 4 would be 16. So we'll have 16 plus 21i on the top, and then 16 minus negative 1 would give us 17. Once again, I'm going to split that apart. So we'll have 16 over 17. There's my real number. Plus, then we'll have 21 over 17 with an I. Once again, you can keep the I in the numerator if you want. Neither one of these fractions can simplify down any further. So this is my final standard form answer. All right, so take a second, pause the video, see if you can divide and write your answer in standard form. All right, so hopefully we found our conjugate to be 2 plus I, so we multiplied the top and the bottom by that. Went ahead and simplified by multiplying everything out, combining like terms. In the end, we were able to divide terms and reduce them down, so my final answer no longer had a fraction. All right, let's talk about roots of negative numbers. So we have something called the principal square root of a negative number. It says for any positive real number b, the principal square root of the negative number negative b is defined by the square root of negative b equaling I times the square root of b. Okay, it's similar to what we've talked about in the past. Remember, anytime there's a negative number under the square root, then you can think of that negative as negative 1 under it, and square root of negative 1 is I. And then you can just simplify whatever that square root of b is after the fact. Okay, so when performing operations with square roots of negative numbers, always begin by expressing all square roots in terms of I. Okay, we want to get rid of that negative under the square roots so then we can actually simplify and get a real number from what would be left over under the square root. Okay, so let's perform some operations here and we'll write our answer in standard form. So in the first one, we have the square root of negative 27 plus the square root of negative 48. So in this case, both of the numbers under the radical are negative. So my first step is I can think of that as a negative 1 under a square root. So I move that I to the outside, and now I just have the square root of 27 that I can deal with simplifying. Same idea here. Move that negative to the outside of the square root, making it an I. And so now I can just focus on simplifying the square root of 48. And then remember, start by looking for those perfect squared numbers. 27 is 9 times 3. Remember, 9 is a perfect square. Square root of 9 is 3. So I get to take that perfect square number and move it to the outside. So the 3 now moves to the outside with the I. And then because this 3 is not a perfect square and I can't break it down any further, that 3 stays underneath the radical. Plus, when I think about perfect squares with 48, I'm thinking about 16 times 3. 16 is that perfect square. Square root of 16 is 4. So I get to move the 4 to the outside with the I. Once again, what do I have left over? A 3. You can't break that down. No more perfect squares with that number, so that stays under the radical. And then the nice thing about this is because you have an I on the outside of both of those, and underneath the radical, you have the exact same number. Those are like terms. So that means that we get to really add the two imaginary numbers together. So 3i plus 4i would give us 7i. And then you keep the square root of 3. It was just like if that was an x, we would add the terms or the numbers in front and keep the x. So it's the same thing here when you have a radical. As long as the number under the square root is the same, you can add or subtract them and keep that number under the square root the same. And that's my answer. In the second one, notice that we have this binomial quantity squared, but the second term inside the parentheses has a negative radical. So I'm going to think of it as negative 2 plus I root 3 being squared. And so anytime I see something that's being squared, I know, hey, I want to think of it as it's being multiplied by itself. So I'm going to write it twice, and now I just want to follow my pattern of how do you multiply binomials together. So I'm going to break apart this first binomial and distribute it to the second. So we'll have negative 2 times the quantity of negative 2 plus I root 3. And then the second half would be a positive I root 3 getting multiplied by negative 2 plus I root 3. All right, so negative 2 times negative 2 is positive 4. Negative 2 times I root 3 would give us a negative 2I root 3. Distributing again over here, the I times negative 2 is negative 2I, but we keep the radical. And then notice that we get to multiply the outside terms together. I times I is I squared. And the square root of 3 times the square root of 3. Because they're both under the radical, you get to think of this as the square root of 3 times 3. That turns into the square root of 9. Notice how that's a perfect square. So essentially, that means that there's no more square root. And now we can start simplifying those like terms in the middle. We've got the same type of number, both imaginary with the same radical. So negative 2i minus 2i would be minus 4i with that radical. And then don't forget, we get to replace that I squared with negative 1. And so now we have one more set of like terms. 3 times negative 1 is negative 3. We get to add that onto the 4. So that would give us a positive 1 minus 4i root 3. Real numbers first, imaginary numbers second. Can't combine like terms any further. That's my answer. In this example, notice that we have a fraction, but in my numerator, I see that I have a negative number under a radical. So first thing I'm going to do is I'm going to simplify it where that I moves to the outside, and now that 12 is just positive under the radical. And so I can go ahead and start breaking up that radical now. Thinking about perfect square numbers, 4 times 3 is going to get me 12. 4 is a perfect square. Square root of 4 is 2. So I get to move a 2 to the outside with the I. The 3 would stay underneath the square root. This is still all over 2. And now all I need to do is, because there's only one term in my denominator, I can go ahead and split apart the fraction. Think of it as negative 14 divided by 2 plus 2i root 3 being divided by 2. Well, negative 14 divided by 2 is negative 7 plus the 2 divided by 2 cancel, and that leaves you with an I root 3. These are not like terms. It's in standard form because it goes real number followed by imaginary number, and so we're done. Once again, pause the video, see if you can perform this checkpoint. Hopefully we were good with coming up with our answer. Once again, that imaginary number moved to the outside. Thought about 18 as in terms of perfect squares. So 9 times 2, 9 was that perfect square, which is why the 3 moved to the outside. Broke those apart and then simplified down my fraction. And so that's us dividing complex numbers as well as performing operations with square roots of negative numbers.